Okay, now if the dimension of the row space of A transpose plus the dimension of the null space of A transpose is less than the dimension of V, at least some, but maybe all, and I'm going to leave that as a question you can think about. And you know, I said more than I need to. Really, what I'm about to say is true. Doesn't care what the dimension of the null space here is. In whatever case, if the dimension of this, which is the range, it's the image of all of V, okay? At least some, maybe all of the vectors in W have multiple preimages in V. Okay? Among other things, the row space and null space meet at the zero vector, right? So here's your zero vector. And here is the zero vector. It's in both the row and the null space. Okay? Your entire null space maps onto the zero vector. And I've said this before, but it bears repeating. So any vector here comes from some vector here, right? Got a preimage. But if you add a vector in the null space to that preimage, it still maps to the same vector. Okay? So, let's see, I'm getting too colorful here. So, this is a W, right? In the range space. Okay? The image of V. Means it comes from something in V. Okay? So, okay, something this one. Okay, let's just say this is, no, let's just say, okay, here, there's another one. Okay? This is a pre-image of W. Okay? So this vector maps to W. Okay? This is going to be the same pre-image, plus some vector from the null space. So this vector is something plus something from the null space. Well, when you transform it, the something is this, and it transforms to W, and the thing from the null space transforms to the 0 vector. So this also has to transform to W. Okay? Because whatever you're added from the null space, because of the linearity of the transformation, that transforms to the 0 vector. Okay? And because of the linearity of the transformation, then, transformation of this plus this is a transformation of this, which is W, plus a transformation of this thing from the null space, which is 0, which still gives you W. That make sense?
So is that why you can't transform from W back to V, because you could get more than one?
Yeah, that's why, in this case, you don't have an inverse transformation. Now, there are all kinds of ways you understand that you don't have an inverse transformation. Okay? Because if you have vectors that map onto 0, that means when you try to row reduce the thing, you're going to end up with rows of zeros, which means you can't have an inverse, which means your determinant is 0, you can't have an inverse. If you have a determinant, if your dimensions are even the same. Okay? And many other ways. If you think of row reducing the matrix, you're going to end up with rows of zeros. You're not going to be able to come back. You only have an inverse if the dimension of this space is equal to the dimension of this space and the determinant of the matrix is non-zero.
Right.
Meaning that your null space is just a trivial 0 vector. You don't, nothing else maps onto 0. Okay? So all those characteristics hold together. Okay, but the key for thinking in terms of the least squares model is that you got multiple pre-images over here, and also that what you're trying to match up, okay, you can have a vector over here, looking for a color I haven't used. I haven't used them all. What haven't I used? Okay, I've used red, blue.
You got blue up there.
Yeah, I haven't used blue. Okay, started to reach for it. Okay, so here's a vector. It's not an image of any vector from here because all these vectors go here. But it is a sum of something here and something here. Okay? So what we want to do is we want to match up this vector with the vector over here. Okay? That brings us closest to the range space. All right? Now that, I'm just throwing that out to get your mind a little more confused so we can resolve it, because it'll take us another day at least to do this, okay? But you see, this vector projects into this space by something in the null space. And by analyzing that projection, we can fit a straight line to our data in a way that I'll kind of talk about, because I don't want to go much further. I want you to really kind of lock in the idea of these spaces and some of the characteristics. And ultimately, we're going to prove some of these characteristics. Like, prove some, maybe all. Okay, well, I kind of told you that. If you think about what I just said, you can see which it is. But we're not going to go into that detail now. I'm trying to give you the picture, okay?